Adam Muzzin. 20 years, man.
Yes.
Professor of astronomy at URQ.
Indeed.
And you and I go way back. U of T. This is what, 1998?
Yes.
And you managed to do something which was, I think, really, really cool. You followed through with a whole bunch of things that I never dared, which was you became an academic, and now you're doing some awesome stuff. So what are you up to these days?
What am I up to these days? So lots of stuff. I think the thing that people find really exciting is so I study galaxy formation, trying to figure out how galaxies got here in the first place. And for your listeners, I don't know how much everybody knows about galaxies, but we live in a galaxy, which is the Milky Way. And you can go out and see it. It's filled with like 100 billion stars, of which our sun is but one. And the universe is filled with hundreds of billions of galaxies. A lot of them look a lot like our own, but we don't really know how they got there, right? We know the universe started with this big bang somehow, right? Everything expanded away from everything. And then somehow, galaxies form, stars form, planets form, people come about. And that's what we're trying to figure out is, where did the galaxies come from? And so the kind of stuff I do is I look at really, really distant galaxies, the furthest ones that we can see away from us.
So why distant? Why does distance matter?
It's a good question. So, it's not just bragging rights, like we saw the most distant galaxy, so
okay.
Ha ha ha. It's that the speed of light is finite, right?
Okay.
You know this at some level, the Earth, the speed of light. If you travel at the speed of light, you go around the Earth 7 times in 1 second. It's fast, but it is finite. And so if you look at things that are, say, 10 light years away, you see them as they were 10 years in the past. And the thing about distant galaxies is if you look at them billions of light years away, which is what we do, you see what galaxies looked like billions of years ago. And if you're trying to figure out how did they form, how did they evolve, how did all of this come about, looking at distant ones is like looking at baby pictures of our own galaxies, and we can actually start to learn something about where they came from.
So in a strange way, you're kind of almost, you're looking back almost at the formation of what, like us, like there would be a similar story maybe out there that might have like the qualifying conditions even for life.
Absolutely. I mean, that's a big step from the initial seeds of galaxy formation, but ultimately, yes. I mean, we try to look at things, for example, that we think might eventually become galaxies like our own Milky Way, right? The Milky Way, we think, is something like 10 or 11 billion years old. The universe, we think, is about 14 billion years old, so the Milky Way forms a few billion years after the Big Bang. But we have no idea what it looked like when it was forming. We have all these guesses, right? We think it was probably this like chaotic mess of like gas coming in and, dark matter and stars forming like crazy and a black hole and all this nutty stuff happening. But we've never seen it, right? And, seeing is believing at some level. And so what we're trying to do is, take pictures of all this very, very early stages of galaxy formation, all this chaos, and somehow, figure out how all this chaos turns into this order that we see now. We have this nice, disk galaxy that's going around, all filled with stars, filled with wonderful planets like our own, right? So that's kind of the game that we're working on. And there's all sorts of exciting stuff coming up in the next few years that are really going to completely change the game for doing that for us.
So does it, I mean, you're so deep into it, but for an everyday kind of lay person like me who looks at this stuff, I mean, the magnitudes of time are like literally on billions of years. I get impatient if something takes me, like 3 minutes or something's too late. And then you're describing stuff on the order of like billions of years. I mean, that's a long time to kind of wait around to see something. And but you're talking about interesting developments happening in like the next little while. Is that we're about to see some things that are about to happen, or we've seen certain astronomical or kind of cosmological events that are occurring as of late? I mean, can you kind of dig into that?
Yeah, absolutely. So the thing we're all really, really excited about is this new telescope that's coming. It's supposed to launch in March of 2021. It's called the James Webb Space Telescope. It's NASA's successor to Hubble. So, probably people have heard of the Hubble Space Telescope. It's pretty famous, and it's been around now for almost 30 years. And it's completely changed astronomy, right, in so many aspects. And it's brought astronomy to people with all these beautiful pictures. And for those of us who are really interested in, the earliest times, just about everything we know about the earliest times for galaxies comes from the Hubble telescope. But, it's kind of run out of gas in some ways. It's only so big, and even worse is it can only go so far into the infrared.
So why does that matter?
Yeah, good question. So you and I were talking about this a little bit before we started taping. Everything in the universe is moving away from everything else because the universe is expanding.
Okay.
And so when things move away from you, their light actually gets shifted into the red. It's the same kind of thing it's the same kind of thing as the Doppler shift here on Earth, what is the Doppler shift? But you know how you're being chased by the police, which is
very often.
Yeah, it's a common thing.
In my case, so.
Yeah. Well, I know how fast you drive.
This is true.
But when the police car's coming at you, the wail of the siren is quite high pitched, and then it goes past you, and then the wail of the siren actually becomes quite low pitched. And this is this Doppler shift, that sound waves become compressed as they move towards you, and then they get stretched out as they move away from you. Light behaves exactly the same way as sound, and so when things are moving away from you, light waves get stretched, and they go to longer and longer wavelengths, which means, the kind of light that you and I look into, the visible, gets stretched into the infrared.
So we can't see that stuff, but
Absolutely.
Those are the types of things that you're studying really that are really far out, so they're, in a sense, redshifted.
Exactly.
Okay.
Yeah, exactly. And so Hubble has the ability to look a little bit into the infrared. And so everything we've learned about very distant galaxies, we've learned from the very reddest thing that Hubble can do. But the James Webb Space Telescope is so much more powerful than Hubble. So the mirror is almost 3 times larger.
Oh my God. Okay.
Yeah. And it goes, much further into the infrared. And so if you think about it, we're trying to look at the most distant galaxies. They're going to be further away, so they're going to be fainter. So we need a bigger mirror, we need a more powerful telescope, and then we also need to look into the infrared because everything is incredibly redshifted. And so this new telescope that they're building, the James Webb Space Telescope, does both of these things. Now, the thing that will scare you is that, it comes at an incredible price. So we've had a few mission delays, and right now this is the most expensive single satellite that NASA has built at a cost of $10 billion with a B.
Okay, so I can't put this clearly on my credit card. It's slightly more expensive than that. $10 billion, that's a lot of money for a telescope.
That is a lot of money for a telescope.
So tell me, people keep, they're going to rag on this. They're going to go, you know what, we're spending a lot of money on science. Why are we spending money on this telescope? Why does astronomy matter? I know my personal reasons for it because, it fascinates me. There's a lot of stuff that kind of frightens me, black holes, this cosmological horizon, which I will pick your brain on in a second. But why, what do you say to people when they say, we're spending all this money on science, especially astronomy? Why does it matter?
There's so many reasons it matters. I can tell you a few of them. Some of the obvious stuff, if you're thinking from a business standpoint, is technology development. CCD cameras, all of this kind of space stuff is stuff that ultimately gets used in the private sector. NASA does so much technology development. So a lot of this money, you think, oh my God, $10 billion, right? Where does this go?
Yeah.
But a lot of it comes all the way back around in a circle. It's a long circle, right? Because it is this technology development, and then it has to get privatized, and then monetized, and et cetera. But NASA has seeded so much technology that's come back. I think the other thing that if you're interested in where it goes is it goes in training people. We were talking before. You have a science background, right? Absolutely. And there's so many people that ultimately go into science that learn, how to be scientists and work on these kind of projects. Many of my graduate students work on these projects. And then they go on and take that knowledge and move it into the private sector. Many of my, former graduate students are working in data science, working for, what are they working for? Banks, working for Facebook, working for booking.com, all these kind of places where they've taken, learning how to analyze real data and then use those skills in the private sector. So we're developing technology for the private sector, we're developing knowledge for the private sector, and then, but that's also not how we think about it. The other reason for this is I think just, the beauty of dreaming, of being a human and wondering, where did everything come from? Why am I here? Why is the Milky Way here? Why is there life on Earth, right? These are questions that I think any of us who have, I don't know, sat out in the backyard and looked up at the stars with a beer have been thinking, like, how did all this happen? And we're trying to answer those questions. And I think people want the answers to those questions on top of all of it. So it is expensive, but, we provide technology, we provide training, and we answer, I think, exciting questions. And so I think it's worth the money. It's a lot, but I think it's worth it.
When you frame it that way, when you say that, and you and I had this discussion earlier on, right, where we talked about how the entire space program, the kind of 50s, 60s, really inspired the entire kind of microprocessor and transistor race, and all like microelectronics. So much of that came from their lasers. All these other lasers came from there. And even, so much of the computer industry, we owe kind of a debt of gratitude to that entire that endeavor, and that I wouldn't frankly be in my industry if it wasn't for from this to say from the entire space race. I wouldn't be here if it wasn't for that. So I think, to your point, we do kind of owe a debt of gratitude to that for dreaming. But, for as long as I can remember, I was also a fan of Star Trek, right? Like the entire point of, these phones and these iPads and, big screen TVs and all this stuff is, and just Skype, the entire point of like visual communication was inspired by these people who had no idea. They just kind of had to make it up. They dreamt.
Yeah, absolutely.
And the entire concept of, warp drive, faster than light, and they didn't have the science, so they kind of thought it up and they just abstracted into this black box, and that here we are today. We kind of take for granted. So I fully agree, and into some sense I think people do need to see that these types of sciences, these empirical sciences, are like very much inspirational, and they constitute the base for so much of the stuff we do.
Well, let me give you another example, right? Everyone is really excited by SpaceX, right? Elon Musk is awesome.
Yes.
All this kind of work that SpaceX is doing, and they are, and Virgin Galactic, right?
Yeah.
Who are struggling a bit, but are I think
Bezos
getting things
right too. So
yeah, exactly. Yeah. And so, space is being commercialized. Ask yourself if that would be possible without the steps that NASA has taken since the 1950s, right? They have, what is SpaceX doing to get off the ground? They are supplying the International Space Station with supplies, right? They're not building a space station. No one can start up a company
right.
to build a space station. It's a tens of hundreds of billions of dollar endeavor to build a space station. But you can start to supply the space station. And now they're working with putting manned spacecraft on the end of SpaceX's rockets, right? So it's a procedure where government and NASA blazes a pathway in something that's just not financially viable today, but in the future will be, right? And all space business that gets done, I think, when you and I are very old men, you will have to say thank you to NASA and the government for blazing that trail, right?
Are you seeing, even from your position right now, a little bit of the erosion of that, or are you seeing more popularity, like stuff is getting in the news and you're seeing more people come into it, and kids these days are fascinated by science? They're going, you know what, I really want to find out, or I want to build the next rocket that's going to land back down, as opposed to just having these parts fall off into the ocean, right?
Right.
That we can just it's possible to recycle it. Are you seeing more interest in STEM and particularly for astronomy, astrophysics?
I'm still a young professor, but I think the interest is there. That's always been there. There's tons of people who want to do that kind of stuff. People are really excited by that kind of stuff. I think it's scary getting into it because it's such a huge industry. But I think there will always be people who want to do that.
It's not gonna, in my hope, it's not gonna die anytime soon, because everyone just wants to go and become a data scientist or make the next social network or something.
No, young people are incredibly inspired, right? That's another great thing about doing this kind of blue sky science, is that it's the kind of stuff that really inspires young people. I'm sure there are lots of inspired tax accountants. You know what I mean?
Yes.
But I would place them against my young astrophysicists, every day in a competition of who's feeling more inspired on a given day, and I think we would fare extremely well, right? People are really, really keen to make advances for mankind.